Hello, Algebra 1 students. Today we're going to be doing Chapter 6, Lesson 3, which is about exponential functions. Please have your journal open to page 180. An exponential function is a non-linear function that is written in the form y equals ab to the power of x. A and b are going to be numbers. A cannot be 0, and b cannot be 1, and it must be greater than 0. So if you look at this picture here under core concepts, when you're graphing, if you have b is greater than 1, you're going to have a graph that's heading up if your a number is positive, and you're going to have a graph that's heading down if your a number is negative. If you have your b is a fraction, like in between 0 and 1, like 1/2 or 1/4, then it's going to be an exponential function that's decreasing, like so, if your a number is positive, and it will look like this if your a number is negative. Let's take a look at the parent function for the exponential function. Remember, your parent function is the most basic of the functions. So if we take a look at our most basic exponential function, a would be 1, and b is not allowed to be 1, so b would be 2. So this is the most basic of the exponential functions. So what we're going to do is we're going to plug in some numbers for x, and I just chose these 5 numbers here, and we're going to see if we can find out what y is. So if we plug in -2 for x, that would be 1 multiplied by 2 to the -2, which is 1 over 2 squared, so that would be 1/4. So if we plug in -1, 1 multiplied by 2 to the -1 is going to be 1 over 2 to the power of 1, which is 1/2. If we plug in 0, 1 multiplied by 2 to the power of 0 is 1 multiplied by 1, which is 1. We plug in 1, 1 times 2 to the power of 1, 1 times 2, which is 2. And lastly, plug in 2, and that's going to give us 1 multiplied by 4, which is 4. You'll notice that each time in this case, it's multiplying by 2 each time, right? That means that it's growing exponentially by 2. This number here will tell you what the growth factor is. In our case, since the growth factor is 2, we are multiplying by 2 each time. And the 1 here tells us where the y-intercept is, okay? So that's going to be your y-intercept. So your a number would be your y-intercept. The only time an a would not be a y-intercept is if we were to add or subtract a number onto the end of the function. Then it's going to shift the whole entire function either up or down, so the y-intercept will change. So now I'm going to graph this function. I'm going to start with 0, 1, and then we double it and go to 2, we double it and go to 4. So even though I didn't plug in 3 here, if we did, we would double it and go to 8. Notice each time it's doubled, so 4 would go all the way up to 16. And then going in the opposite direction, we go to 1/2, and then 1/4, and then it would be an 1/8, and it would be closer and closer to 0. It would never actually get to 0. And so 0, it'll never cross, it'll just get closer and closer and closer. So this is what our exponential function looks like. Once again, that is the parent function. All of the other functions that we graph, all the other exponential functions are going to be based upon this parent function. So I'm going to remind you now about the transformations. A long time ago, I had you watch a video about transformations. So if we have the parent function y equals a b to the x minus h and then plus k. So remember, this is your y-intercept unless you are adding or subtracting. So this is where you're going to start, and then if you shift it, it'll be shifted either up or down by that letter K. The B number here I said is the growth factor. It's also, some people call it the multiplier. So this is what you're going to be multiplying each number by. And then this here, where you're adding or subtracting a number in the inside of the function, that's going to be a shifting to the left or the right. On the next page, on exercises 1 through 4, we want to decide whether or not this is a linear function or an exponential function. Remember, linear is what happens when you add or subtract a number, the same exact number each time. It's going to turn into a line. And exponential is if you look at these numbers and it's a multiplier instead, so something's being multiplied each time, then it's going to turn into an exponential function. So let's take a look at number 1. So if we look between 8 and 4, and then 4 and 2, and 2 and 1, it's 8 minus 4 is 4, and then minus 2. So we know that it's not linear. So let's see if there's a multiplier instead. So one of the ways to decide if it has a multiplier is by taking the number that's after it, so in this case 4, and dividing by the number that's before it would be 8. So 4 divided by 8 is 1/2. So that means this is a multiplier of 1/2. And let's do the next one. So 2 divides by 4 is also 1/2. And lastly, 1 divided by 2 is 1/2. So this has a multiplier of 1/2 each time. That means that it is an exponential function. Let's take a look at number 2. So number 2, we have 3 going to 7, and then to 11, and then to 15. So that is adding 4, and it looks like it's adding 4 again and adding 4 again. So this time, since we're adding or subtracting a number each time, it will be a linear function. So let's take a look at number 4. If I think about number 4 as a linear function, on this one we're adding 0.375. And next, we are adding 1.5. So we know that this is not going to be a linear function. So let's see if we can find out what it's going to be, what the multiplier is. So remember, once again, you're going to take the second number and divide it by the first. So 0.5 divided by 0.125 equals 4. So this has a multiplier of 4. And this also has a multiplier by 4, and this also has a multiplier of 4. So that means it is an exponential function. I would like for you to do number 3 on your own. For number 3, I got linear function. For exercises 5 through 7, all they are asking us to do is to evaluate the function for the given value of x. I'm going to do number 7 with you. So all they're asking us to do is to take the x is equal to 4 and substitute it in for the x on the function. So y is equal to 3 times 4 to the power of 4. Now you need to remember that we need to use order of operations. That means that my exponents come before multiplication. So this is going to be 3, and then 4 is multiplied 4 times. And I would suggest using a calculator for this. So this will be 3 multiplied by 256, and the final answer is 768. I would like for you to do numbers 5 and 6 on your own. For number 5, I got 243, and number 6, I got 1 over 64. In exercises 8 and 9, we want to graph the function, also compare it to the graph of the parent function, and we need to describe the domain and range of the function. So the first thing I'm going to do is I want to think about what the parent function is. So I'm going to put that in the middle here. So the parent function is y equals 1 multiplied by 2 to the power of x. So let's go ahead and just graph that really quickly, just to remind ourselves what that looks like. So remember, the y-intercept is at 1, and then each time it's going to double. So at 1, it's going to go up to 2. At 2, it's going to go up to 4. And then at 3, it'll go up to 8, 5, 6, 7, 8, and so on. And then each time here, it's going to be halved. So get closer and closer and closer to that x-axis without actually ever touching it. All right, so that is our parent function. So if I look at our function on number 8, this is the same as -1 multiplied by 2 to the power of x. You'll notice that the only way that this is different than this one is that instead of a positive 1 here, it has a -1. And if you remember, when we're multiplying by negative on the outside of the function, what's going to happen to this is it's going to be mirrored over the line. So instead of coming up like this, it's going to be here and it's going to go down. Okay, so that's what it's going to look like. That's what we can expect. So that means that our x and y axis will have to go, the x-axis will be all the way up at the top, and then I'm going to put my y-axis in the middle. Okay, so let's go ahead and plug a few numbers in. So if I plug in -2, that's going to be -2 to the -2. So that's going to be, remember this negative, if there's not parentheses, this negative stays, right? So this will be 1 over, so negative stayed there, so 1 over 2 squared, so that's going to be -1/4. So then I have -2 to the -1, so that's going to be -1 over 2 to the power of 1, which is -1/2. Next, we have -2 to the power of 0, so that's going to be -1, and -2 to the power of 1 is going to be -2, and -2 to the power of +2, so that'll be -4. So when we graph it, we're going to have -1 is our y-intercept, and we're going to double it each time going down in the negative direction. So when we plug in 1, we're going to get 2. When we plug in 2, we're going to get 4. And then 5, 6, 7, 8 will be down here. And I don't have room for 16. And then each time it's going to get closer and closer and closer to that x-axis. So as you can see, this new graph here is going to be a mirror image of our parent function because it's reflected over the x-axis. So it asked us to compare the graph to the parent function. So that's what I'm going to say. I'm going to say it is reflected over the x-axis. Now we need to say what the domain and range is. So the domain, if you think about the domain, remember, are what x's can we use? Well, this is an arrow going to the left, so it's going to continue going forever and ever and ever. And this arrow is going also down, but it'll always head out to the right. So the domain will be all real numbers, and our range is going to be all the numbers that we're not going to include 0, but everything below it. So the range will be y is less than 0. Let's take a look at number 9. So number 9 has a y-intercept of 2, and this time our multiplier is a fourth. So that means it's going to be getting smaller each time, so it's going to be a decay. Okay? So it's going to look kind of like what we have here. This is going up, but instead it's going to be coming down, and it's going to be have a y-intercept of 2. So that's the first thing I'm going to do, is I'm going to draw my y-intercept of 2. And our multiplier is a fourth. So that means if I started at 2, if we plug in a 1, it's going to be 1/4 of that 2 that I started with. So that'll be 2/4, which is 1/2. So if we plug in 1, it'll be a fourth of that, which is down to a half. And then it's going to be a fourth, and it's going to get closer and closer. So notice that each time it's heading in this direction, it's going down by a fourth, which means if we go in the opposite direction, so going and plugging in negative numbers, it's going to be a multiplier of 4, so it's going to get much bigger. So that means if we plug in -1, we're started with 2, right? That's our beginning, and we're going to multiply it by 4, so that'll be up to 8. And if we plugged in -2, we started with 8, we're multiplying by another 4, it would be up to 32. So obviously we don't have room for that. So this is um, our, our new graph there. So what happened? Well, we can say that it has a y-intercept of 2 instead of a y-intercept of 1, and it has a multiplier of 1/4. So whenever you have a multiplier that's between 0 and 1, you're going to have the graph decreasing instead. Now let's talk about our domain and range. So our domain, once again, it's going to be all real numbers, just like it was on the other one. And my range is going to be everything that, since it's above the x-axis this time, it's going to be everything from, not including 0, but everything above 0. So we're going to write that as y greater than 0. All right, let's take a look at number 10. We just need to graph the function and describe the domain and range. Now, I always like to compare it to the parent function, just like we did before. So our parent function is 1 multiplied by 2 to the power of x. So I'm going to go ahead and really quickly draw that in again. So we have our y-intercept of 1, and we're going to double it each time. All right, so let's take a look at number 10. This time my multiplier is 4. And I can put a 1 out here. That'll be my y-intercept. Ah, but wait a second. It's also going to shift down. So it won't be my y-intercept, but I'm going to use that to help me. So we're going to shift down 2 units. So I'm going to put my x-axis here since we're shifting down a little bit. And I'm going to put my y-intercept here. So I'm going to first just graph in green, I'm going to do f of x is equal to 1 multiplied by 4 to the x, and then I'm going to shift it down. So if I just graph that first, I'll have a y-intercept of 1, and I'm multiplying by 4 each time. So 1 times 4 is 4. And then 4 times 4 is 16, and I don't have room for that. So I'm going to be going, and it's going to get smaller and smaller. So it's going to be going really, really, really steep because the multiplier of 4 means that it's going to get really, really big really fast. So now with a different color, I'm going to use my black pen. I'm going to do f of x is equal to 4x minus 2. So what I'm doing is I'm just subtracting off 2 each time. So that was at the y-intercept was at 1. Now it's going to be shifted down, and it's going to become a y-intercept of negative 1. And then this will be shifted down to here, and so on. So these will get put down a little bit as well. So we're going to be going like so. All right. Okay, so now let's find the domain and range. The domain of this is going to be all real numbers again. And the range, so it was everything greater than 0, but since we shift it down, it's going to be everything greater than negative 2. So that means we have y is greater than negative 2 for our range. All right, let's take a look at the next one. We have a y-intercept of 4, and we have a multiplier of 1/2. So that means that we're going to be getting smaller and smaller each time. And I also have a shifting to it's going to be +1, so that means it's shifting left. Remember, it's opposite of what it is when it's inside the function, left 1 unit. Okay, so what I'm going to do first is in green, I'm going to do f of x is equal to 4 times 1/2 to the power of x. So I'm going to ignore the shifting first because that's the easiest part to do first. So we are going up, so I'm going to be putting my x-intercept there, or my x-axis there. Okay, so we have a y-intercept of 4. So in green, we're going to go 1, 2, 3, 4. We're going to be putting our y-intercept here. And we have a multiplier of 1/2. So we're going to take half of 4, which is 2, and then half of 2, which is 1, and then half of 1 is 1/2, and then 1/4. And so this is how we're going. Now, when we go in the opposite direction, we're doubling it, right? So when we plug in -1 instead of 4, it'll be up at 8, and then it'll be up at 16, and we can't really get that far. So this is what the graph looks like before we do the shifting. So now we're going to shift everything to the left 1 unit. So that means that all of my points are going to just be moved over to the left 1 unit, and that will be my actual answer here. So here is my my new graph, or that's my answer graph. All right, let's find the domain and range. So the domain is all real numbers again. And the range is going to be, notice that the range is everything above the x-axis again. So the range will be y is greater than 0. In exercises 12 and 13, we need to write the exponential function. So in number 12, I see that my y-intercept is here, And my multiplier, we take the number that is after it and divide it by the number that's before it. So 18 divided by 3 is 6. So that means that my multiplier should be 6. So I can double check that 18 times 6 does equal 108, and 108 multiplied by 6 does equal 648. So my multiplier is 6. Okay, so now we just need to write the answer. So y is equal to my y-intercept multiplied by my multiplier to the power of x, and that's the answer here. So number 13, I see that my y-intercept is here. And to find my multiplier, I need to use the whole numbers. So I'm going to use these numbers here, which is -2 and -0.5. So we take the number that's after it, so 0.5, -0.5, and divide it by -2, and that equals -0.25. So that's going to be my multiplier. Okay, so now my answer is y equals my y-intercept, which is -0.5, multiplied by my multiplier, 0.25, to the power of x. And so that would be my answer for number 13. On number 14, we need to graph these two functions. So I'm going to start with this function here, which is our parent function, and then our next function I'm going to do in a different color. And notice that all I'm doing is shifting up 3 units. So our parent function here has a y-intercept of 1. So we'll do that. And then it doubles each time because that's my multiplier. So multiplied by 2 gives me 2, sorry, yeah. And then multiplied by 2 again is 4. And then 5, 6, 7, 8. And then it would be 16. So in the other way, we're having it each time, getting closer and closer to that x-axis without ever crossing over it. So that is my parent function. So now we're going to do the new function, and everything basically just gets shifted up 3 units. So this is 1, 2, 3 is now going to be here, and everything, so that's 1, 2, 3 is going to be here. And so everything is just getting shifted up 3 units. And you'll notice what happens then is that the domain and range, so the domain doesn't change, right? It's asking us to say what happens, what's affected. So what happens with the y-intercept is that the y-intercept gets shifted up by 3 units. The domain stays the same, and the range also gets shifted up by 3 units. Okay, that's it. Thanks for watching.